git checkout, git branch, git checkout, main, git pull. So in the main branch, it will update the latest changes. So git branch again, git checkout, -b, class 06. So no more things are needed. But if you see git status, it is clean. Now going further. So what we will learn in today's class? It is 2nd of Feb 2024. Yesterday we have seen about the operator precedence in arithmetic operations, but still there are few arithmetic operations that we need to go through. We have seen like different kinds of arithmetic operations, starting from say the basic arithmetic operations like plus, minus, addition, subtraction. And within the division also I told there are 3 types of things. True division, floor division we call, or like quotient, and modulo division or remainder. And then multiplication operator. Then like, power operation. There is another thing called as power operation. So like single star, there will be 2 stars. So that's one thing. Power operation. And so going further into this, we can see that I showed you about the power operation. Power operation can be done using the power operator. But before the power operator was invented, so they don't have an operator to do. That's where like they worked on something called as power built-in function. Means like earlier in the Python 2, so when this was introduced, before that, they don't have any operator. So they created a power built-in function. So nowadays, very few people are using, but still this built-in function is there. So it will do the same task as what you give. So anything to the power of like that. So similarly, this power operator can do one more extra thing than ordinary power operation. See what you do in a traditional way, the same thing we can do like this. But apart from this, this power operator will do one more extra task. The task is like we can give like 3 values and it can give the output. Generally, we know we can give 2 values, right? But if I give 3 values also, it will give. Sir, this will be the base, this will be the mantissa. Then what will be the third value, sir? Means it will do the modulo division. Means it will do exactly like this. To give an answer, if I do this also, I get the same answer. Means for the first 2 values, it will do the power operation, and the remainder it will do like this. So that's how you get it. So now, means like there is one more operator I want to introduce you. This is called as equivalence operator. Means in the left hand side and right hand side, if both are equal or not, we can check using this. If I say 2 equal to 2, whether both are equal? Yes. Similarly, if I say number 1 is equal to say 200, number 2 is equal to 200 again. Now if I say number 1 is equivalent to number 2, observe the difference. This is assignment operator. This is a equivalence check operator. It will check whether both sides values are equal or not. So as I told that these both operations are doing the same output, can I try and check the output like that? I can say like power of these two is equal to 2 equals. In JavaScript, we have 3 equals. That is a different thing. In Python, we have 1 and 2 equals only. So 4 to the power of 2. So modulo division 9. So both will give the same answer. So today I introduced you one more relational operator called as equivalence operator. And then one more thing within Python is that there is a concept called as exponential notation. It is nothing new with Python, but generally, whenever you are working with the smaller values and larger values, So for better, memorization and working, so people write like this. If someone asks, hey, what is the largest numbers, like Avogadro number, or like, so what is the velocity of light and all these things? You don't give like a big numbers, right? The real number may be slightly big, but we try to give in a way that people can understand. So means like if I say velocity of light is equal to 3 into 10 to the power of 8. That's what we generally say, right? So it's like for working with large and small values, it is kind of a notation. Mathematically, it is there. So everyone will use it. In Python, we adapted like this. We use a nomenclature called as E. If I just like E, then it will throw an error. If I say just like E, so it will throw an error. But 1E1 means it will give an answer. That's a difference. So 1E1. Or if I say like E1 also, it will think like E1 is like an object, right? It will think like that. But if I say like 1E, even in that case also it will think like that. So 1E1 means then it will think. Not just 1E1, you can say 3E1, 5E1, whatever. So if I say like 3E8, like this. Or similarly, I can write something like 3E2. 3E2 means I got like this. Means 3 into 10 to the power of 2. So 3E say 12 if I give. It will be a bigger number. So similarly, if I give like minus 2.3 E4, means minus 2.3 into e to the power of, e means 10 to the power of 4. So you get like this. So like that, we can write a larger and smaller numbers. Next, coming to the big things. Whenever you are representing a large numbers, what is the solution? So there is a concept called as number formatting actually. So for that, let me take another one more operator to work with it to show the things better. Yeah. Say whenever if you are want to represent a large number, there is called as like a number formatting. Number formatting. It is basically useful whenever you want to work with a larger numbers. So if I want to make it like a markdown, I can do like an escape M. That is a shortkey for converting anything to a markdown cell. So here, generally, if I have a number which is small enough, I can just take a number and print it as it is. But whereas if I have a large numbers, so that's where I need to be worried. When I have a large number, generally if I give a big number like this, do you think it's easy for anyone to remember also or even spell also? It's very difficult. But that's the reason in real time what you do, hey, instead of writing this number, you write the same number, comma separated, you remember? So when you are writing on a pen and paper, so tens, thousands, hundreds, for every 2 digits or 3 digits, you place a comma, right? But if you do the same thing here in Python, it will treat it like a separate data type called as a tuple. It is treated as something called as a tuple. But sir, what if you want to make it readable, but it should be treated like an integer only? For that, they introduced a concept called as underscore. You may think it is something weird, but it is actually works perfect. It is for our humans to understand whether it is like, floating point value or like integer. Say if I make it like a floating point value, say like a dot, and before that also if I place some underscores at discrete amount of times, when it processes any number, integer or float, it will try to check for any underscores and remove them. In this way, it is very easy for human beings to read, right? So just to give this clarity in one shot, I'm trying to show you that. So let's take the example of previous one, the speed of light. Generally, if I have speed of light, it can be like this. So if I do like a comma separated values, so then what it will think? It will think like these are three separate values and it will treat like a tuple. But if I take like an underscore, then it will treat all of them in the. And also, if I do like an underscore again, You see here, in this case, what happened? In the first case, it is treated as an integer as it is. Second case, it is treated like a tuple. So because comma separated. But if you are writing like an underscore, again, it is treated the same way. Sir, what happens if you have an underscore, but it is stored in like a quotes? So no matter if anything is stored in a quotes, it treats like a string. Every character will be treated like a ordinary string character. Everything will lose its significance. So the same thing works even if you go for a smaller values. Smaller values means, say, if I go for like 3.1415 something, pi value, right? Even post decimal also, if there is a underscore, it will try to ignore that. If you place it, so I gave it an underscores and exponential notation also. Then it is treating and giving us the answer. So I told you how to work with smaller values, larger values, and all those things. And if you see any number, if I give like any number of underscores, it doesn't mean for every character or every alternative character, every 2 or 3, it just takes. This is all for our convenience. So what if I have placed like this? Is it correct or wrong? If you can observe here, I have placed more than one underscore, right? Means for every character or 2 characters, you can write an underscore. But there should be only one underscore. If you have more than one underscore, it will treat like a variable. So it is kind of like a invalid. So no more than one literal is accepted. So we can write that note and we can stop. Hope you understood. Okay. So that is how it works. Now, going further, we understood something about this arithmetic operations, formatting, working with large numbers, and all this story. Now let's work on something like a real-time example. Say I'm working on something called as a ration store. Ration store, you can understand, right? How a ration store works. So in ration store, what is the concept? Any program when I'm starting, it's not a mandatory, but if I want to run like in a Linux, I can do like the shebang line, as I told you. And within the doc strings, we should write what is the purpose of this program. Are these mandatory? No, it's a best practice. So here, I want to tell what is my purpose. Means I want to create a ration store. So first, what is the problem? So what we want to solve. Typically, if you go for any ration store, so the quantity will be predefined and the price will be predefined. You need to go pay and come back. Okay. So on the particular month, the rates will be fixed. Your quantity is fixed. If let's say wheat is costing like 25 per kg, so quantity is like 30 kgs, and you need to pay this much amount. Cost into quantity. Similarly, rice, you need to price cost into quantity. Totally, how much you need to pay? This amount plus this amount total. In that, if you assume that on a particular month due to famine or something, you got some subsidies. Subsidy means you need to subtract that from this original value and finally get. As a human being, it's very easy for us to understand. Now you get to know the programming when you try to implement these common problems into a program. How do you convert this into problem? That's where you need to understand what is an algorithm, how to write it. Say, for this particular thing, if I want to implement, I can think about writing a algorithm. So what is the algorithm that I can envisage? So first, I need to get the costs, right? Cost of this item. So step one, get the cost of items into a variable. So what I can do? What is the cost? Cost of item. So first, cost of wheat, right? I can use like an underscore case. You see, I told Python says that by default, you should go for underscore case for everything except for the class names. So when you have a meaningful name, it can be more than one word. You can combine them with an underscore. Cost of wheat. So wheat is equal to 25. So cost of wheat is 25. So maybe like if you want, you can say per kg. Per kg. See, I wrote like a comment in the starting. This entire line is comment. So this line from here onwards, it is comment. Similarly, cost of rice is equal to say 12 per kg for you to better understand. So I got the cost of these things. Now, next thing, get the quantities of the items also. How many quantities you want? So that would be your next step. See how I'm converting a common problem into a code. Similarly, I can write the same thing. Quantities of items, whatever the quantities. When I'm writing quantities, see, I get a meaningful name, 30 per kgs or 50 kgs like this. Fine. Now I got the cost and quantity. Then what I can do? I can calculate the selling price of each item and then can add them. That's what, right? So we need to get the selling price of each items and then we need to add them. So 2 points we have. How do you calculate the selling prices? Cost into quantity. So selling price calculations, if I say, what I will do? Selling price of wheat is equal to, so cost into quantity. Similarly, selling price of rice is equal to cost into quantity. That's how you got it. So what is the next step after calculating? We need to add them. So total selling price is a combination of both of them. Total selling price is a combination of both of them. You got it? So now, if you want to test till here, how whether things are working, you can see that whether you are in that directory, arithmetic operations, we need to go. So if I say ls, I got my code. So which program I have? B, this one, clear and Python B, so and so. You see, you got the selling price. All the computations were done. So don't you see it? Yours is correct? Because the same numbers you placed, you got the same answer. Now we need to calculate what is the subsidy amount, this 270, and then subtract, right? So the next step is like compute the subsidy amount and subtract now. So if I do the same thing now, how I will do? Subsidy amount. So at 20% of subsidy, I need to calculate because that's what is given to us in the top. So subsidy amount is equal to, so subsidy will be calculated with respect to the total value. So total price into what is the subsidy? So 20 by 10. So that's what, right? Either you can do 20 by 100 or 20 by 100 and do like this, or either way. So you know the concept of PEMDAS, right? So first it will be done like this, or if you place like this, then first it will divide and do it. So whichever you do, that is the concept of PEMDAS as I told yesterday. Now, if I calculate and print that subsidy amount, you can notice the same. So if I execute, did you understand now what's happening? You got some value. So I did like this and I got the subsidy like this. What I got? 0.19 I got. But see, what should be the subsidy? 270. But why I got like this? Because I placed the braces like this. If I do the same thing, but slightly differently, if I take this as a brace and I close here, instead of closing the other side, now we see what will happen. The output 0.1 means for everything it is changing, right? The subsidy, the total value that you are getting. Selling price in, so sorry, of course, this is not the operator, in fact. So we should use like a percentile, multiply, right? Multiply into. So like this, you can understand for everything what's happening. So every brace position will make a difference. Whenever you're calculating, first PEMDAS means parenthesis will be executed. After that, exponent. So after that, multiplication. So after that, division. So means if you do like this, or if I don't place any brace, then you tell me what will happen this time. Parentheses are not there, exponential not there, multiplication is there first. So this will be done executed first, then the result will be divided. So it is same as this one, right? So I will comment this and you can see the same output. You see? So that is how it works. Now, if you want to get the final result, what we need to do? So we need to subtract this billing amount. As I told you here, we need to calculate the subsidy. Now we need to subtract and then we need to display the final amount. So now I got a subsidy. Now I want to get the total billing amount. Billing amount means what? From the total selling price, we need to subtract the subsidy. So that's how you got the answer. So did I get this 1080? Fine. So in the process, you learned about different kinds of things. Similarly, let's implement one more practical problem. So with more such problems, you will learn a lot of concepts. Let me take this time a small enhancement to this. Say if I say C fruit store. This time again one more problem. So this time what I want to tell is that I want to create a fruit store. What is the difference from a ration store to fruit store is like you specify the things in terms of the quantities and others, right? Say like I am telling that you need to get these quantities and do. But this time we are having some constants. Dozens you will buy. You will not buy single, right? So dozen means it has some meaning. Dozen means 12. Like that we have some constants. Discount we have. And it's a business, so we need to pay the GST also. Means discount should be removed, subtracted, and GST means tax should be added. So these kind of slight more complications I'm going. So in terms of algorithm, how do you implement? So let's see. Any problem, even when I am learning programming for the first time, first I did like this only. I used to write on a pen and paper in terms of what I need to do, and slowly I used to implement. So first I need to get the cost of the fruits into a variables. That is for sure. So cost means like cost of fruits, which are like apple and mango. What are the costs? 12 and 34 each per piece is like this. So cost of apple 12 per piece. Comments are for our understanding for developers. So doc strings are for creating documentation, which I will tell afterwards. So like this, you wrote the cost. Now what is the next thing? After the cost, you need to write the quantities. So we need to get the quantities. But if you see quantities here, it is saying 5 dozens and 3 dozens. So if I say quantities of fruits, I will start working like that. So quantity of apples is equal to, it is saying like 5 dozens. Say 5 into dozen, can I give? No, dozen means 12. Instead of I implementing, generally in a program, whenever you have constants, we should place the constants in the starting of the program. Or like we need to have like a separate constants or like config file where you need to write. So what is a constant here? Dozen. Dozen is equal to 12. We wrote. Now we use that variable dozen like this. Now in this way, whenever you have a constant, so if you place all of that, constants are something like an assumption to your program. In future, if changes, you can just change there instead of in the entire code. So now in the same fashion, what we can do? Quantity of apples is 5 dozens per, so pieces, dozen pieces, right? And mangoes, 3 dozen pieces. Now the logic is same. So selling price, we calculate individually and add it. In the previous case, I did individually and added. Now here, let me add all of them together. So total thing, what I will do is like, see, total selling price is equal to first cost of apple into quantity of apples plus cost of, mango into quantity of mangoes. Now, if I say, hey, tell me what is the total selling price? That's where you will understand clear and Python C so and so. Now, did you see this total selling price? Now, you understand the concept of PEMDAS. PEMDAS. Do you have parentheses? No. Do you have exponential? No. Do you have multiplication? Yes. So this is one multiplication you have. This is another multiplication you have. So first multiplications happens, then division it is there, no, then addition is there, addition will happen. Means this logic is same as whether you place a brace. But whenever you have a doubt about any operator which may get, so you place a brace, things will be easy. So it should do the same job as previous. Now did you get the same thing? 1944? That's a good thing. So that's how we calculated the selling price. We understood the concept of PEMDAS. Now we need to calculate the discount. So the discount is like 2%. So let's make discount also as a constant. Discount is like, 2%. Means 2 I wrote. So generally, discount calculations, how you do? So we need to multiply with the same thing. So discount amount, if you are calculating, what would be the discount amount? In the total selling price, we need to multiply with the discount and divide by 100. That's what we know standardly. Now, if I ask, hey, what is the discount? You can notice it is 38.88. So you got the same answer. Now we need to subtract the discount. So what is the total payable amount? Payable amount will be selling price minus discount. You got the answer? So 1905, you got 1905.22. 12, sorry. Now, after the discount, what else we have? So we need to work on the selling price. So selling price, GST. So we need to calculate the GST and we need to work. So in terms of the algorithm, if you see here, we got the items, we got the quantity, selling price, we added, discount we added, and we subtracted, we got it. Finally, we need to calculate the GST amount and add it. So with this, we will understand full clear. GST is like 12.5%. So we need to write GST is also a constant. So I'll write GST is equal to 12.5. See, like this, I wrote all the constants and I want to use within my code. So if I say GST, you got it. The GST is payable amount into GST divided by 100. So if I calculate the GST, I got 238. You got 238? So fine. And we need to add this GST such that we will get. So payable amount plus GST, if you add, you will get total amount of billing amount. So generally, if you ask the user to pay this much amount, will they pay? Nowadays, so credit cards came, but earlier people cannot pay, right? So that's why if you see any bill, they try to round off. Whenever you have this kind of floating point values, which are going beyond things, so we can go for some built-in function called as round. So today I'm introducing one more built-in function called as round. Generally, round will take a digit and give you the number of times we need to round off. So if I say this thing and if I'm making to 2, it will try to round off to 2 digits. So did you see now? You got like this 2 digits. So this is what about a new function called as round. So hope it's clear for everyone. Now, one more interesting point about this round, if you see, the round, it is so interesting that it all depends upon what you want. If I say like, so about the round, if I like 2, it will say to 2 digits. If I say to 1 digit, or like if it says 0, or if I don't give also, you see the difference how it will be if I execute. When I do like a 2 digits, it's a 2, 6. Rounding is different from truncating, right? Truncating means you'll get 2 only. But rounding means if the decimal is greater than 5, it will go to the next digit, right? This is all pure math. So that is rounding. And if I say 0, it is converting to 0 digits. So, and you see, it is less than 3. If it is greater than 3, it would have been done differently. So if it is like this, fine. If you don't specify or specify 0, it makes a difference. See here, in this case, it is creating a float. And in this case, it is becoming an integer. So that is a difference that you can learn. Next, after this float, you have something called as a